So now we're going to shift gears a little bit and begin to examine double replacement reactions. Now, double replacement reactions have a particular subclass of reactions that we're going to call precipitation reactions. Okay? So here's an example of a precipitation reaction in this quick short video. Here we have two clear colorless solutions being mixed together, and we're forming a yellow mixture, and clearly there seems to be some sort of cloudy particulate matter forming. This cloudy particulate matter is known as an insoluble compound because it's no longer clear, colorless that the water is. It's opaque in nature and yellow. And that yellow material can be recovered because it is a solid. We call this solid a precipitate. And a precipitate is simply defined as a solid, an insoluble compound formed during a chemical reaction. A solid, insoluble compound formed during a chemical reaction. So these are a subclass of chemical reactions within the double replacement series, precipitation reactions. So they will follow the rules of double replacement reactions where the pair of cations will switch with the pair of anions, forming two new products where the anion pairs and cation pairs have switched, following the same rules, but now we're going to have to be able to predict the solubility of the product. So how will we do that? So let's pause the video here and take a look at these reactions that we have. You can attempt to predict the product of these reactions first, and then we'll go over them together. So let's look at the first one. Here we have silver nitrate reacting with sodium hydroxide. So silver nitrate and sodium hydroxide, both soluble compounds, because we're telling you on the left side that they're both dissolved. And we also know that sodium hydroxide is a group 1 metal interacting with hydroxide in a compound, so therefore all of those hydroxides are soluble. Silver nitrate falls into the group of nitrates where all nitrates are soluble. So if we take a look at this reaction and we switch them, we undergo a double replacement reaction. That means silver and sodium will switch to make, so therefore our product will be sodium nitrate and silver hydroxide. Please remember here that silver has a +1 charge, hydroxide has a -1 charge, so the chemical formula is going to be AgOH, and sodium hydroxide is going to be sodium nitrate. Sodium has a +1 charge, nitrate has a -1 charge, so therefore it's going to be NaNO3. So now we take a look at these two compounds. We now need to predict which one of them is going to form the precipitate in this reaction. So we know already that sodium nitrate is going to be soluble because of our rules of solubility. Or we can just glance at table F and take a look and see that all sodium salts and all nitrate salts are soluble. So therefore silver must be our precipitate. So we indicate that by placing a solid next to silver and AQ next to sodium nitrate. Now let's look at our second example. Here we are looking at sodium nitrate reacting with ammonium chloride. Now both of these compounds are soluble and they belong to the family of ammonium and nitrate salts. So again, we know from before that the cations will switch, forming new pairs. So our product will be sodium chloride, where the sodium has a +1 charge and chlorine has a -1 charge. So the chemical formula for the product will be NaCl. Looking at the second product, it's going to be ammonium nitrate. So ammonium has a +1 charge, nitrate has a -1 charge, so therefore the chemical formula will be NH4NO3. Now, which one of these is going to be our precipitate? It turns out that neither of them will be our precipitate. Sodium chloride is soluble in water. It's part of the group 1 metals, and so is ammonium nitrate. Ammonium nitrate is both part of the nitrate and ammonium family, so therefore the compound is definitely very soluble. So that's aqueous. So what does that mean about this reaction? There is no precipitate that's formed. Since there's no precipitate that's formed, then no reaction has occurred here. So that's important in being able to predict the product of the reaction, is that we can know whether a reaction is actually occurring or not. Finally, let's look at our last situation. This looks a little bit more complicated, where we're looking at copper nitrate reacting with ammonium phosphate. Now please remember that since we have balanced equations, we're now going to need to balance all the equations that we have. The first two examples are balanced already with coefficients of 1. So if we take a look here, we have 3 copper nitrate reacting with 2 ammonium phosphate. Again, now we're going to swap the cations and we're going to produce ammonium nitrate and copper phosphate. Okay. Now please note here that phosphate has a -3 charge and copper has a +2 charge. So the chemical formula is going to be Cu3PO4. And we know from the rules of solubility that all phosphates are insoluble except a small number of phosphates. So here we know that copper phosphate is going to be our insoluble precipitate product. So that ends here our practice with guessing the precipitate. Have a good day.